Today we are going to look at Cloudera operational database to Cloudera operational database HBase replication demo. This is a feature which is available in Replication Manager, and the primary use case for this functionality is disaster recovery. As you know, Cloudera operational database provides our operational database functionality in CDP public cloud. The ability to replicate HBase tables from one COD cluster to a second COD cluster protects the case in case the primary COD cluster suffers a disaster and is not available for any unforeseen circumstances. In this case, the applications can always fail over to the secondary COD cluster. In case of the DR, the another benefit is your primary COD cluster and secondary COD clusters can have different topologies. Your secondary COD cluster, if it's primarily used only as a DR target, could be much smaller in size, and they don't need to have the same configurations on each sides. And finally, the third benefit is this is essentially replicating data from S3 storage. In case of AWS environment, this is replicating data from one S3 bucket to second S3 bucket, which is essentially a lot more efficient in managing data on HDFS. So with that context, let's look at our environment. Here we have a source COD cluster, and let's take a look at the host and the HBase tables on this COD cluster. So if you see in this, we have the HBase service instances, and here we have a master node. So let's log into this master node and see the HBase tables present on the source COD cluster. Yeah, so we have a bunch of tables on the source, few tables of 1 gig in size, few of 10 gig in size, and even a 100 gig table. We'll take some of these tables and set up a replication policy so that these tables are replicated from source Cloudera operational database to destination Cloudera operational database. Let's also take a look at the cloud storage, which is used behind the scenes here. So if we go back to our COD instance and cloud storage, we exactly know the bucket which is used here. And I do have the AWS console for the same bucket. So yeah, if I see the properties of this Cloudera bucket, we see the same tables which we were just able to see from the HBase session. Let's take a quick look at our destination. So this is the destination COD instance which we use for the replication. And looking at the Cloudera Manager instance in it, and the HBase host. For instance, we have a master node. Let's log into this master node and make sure that these HBase tables are not yet replicated on destination. Okay, yeah. So at this point, it only has 2 tables, and let's similarly, just like how we saw the storage used by the source COD cluster, let's confirm the storage on the destination COD as well. So cloud storage of destination, and this is exactly the bucket used by the destination. So we see it has the same tables which are visible to us via the HBase shell commands. So at this point, we have seen the primary setup. Let's go to the Replication Manager app and try to create a replication policy. So in the Replication Manager, we at this point have ability to discover these clusters. It understands Replication Manager app through its single sign-on user, has the authorization where if the user is authorized to discover all the COD clusters, it has ability to find out what would be the COD clusters which could participate in source and the destination for a replication policy. Create a replication policy. I'll select HBase, name this HBase demo 101. So sources, primary COD2. Let's add a couple of tables which we are replicating on the source. It is including the initial snapshot, which it means is any data sets which are present on these tables prior to replication, they are also replicated from source to destination. Let's select the destination, which is our recovery COD cluster. And here the Replication Manager is quite verbose. It will tell you that it's going to perform some of the steps between these 2 clusters. and what are the prerequisites which have to be performed. It also provides the option to do rolling restarts, which essentially is a non-disruptive operation on your COD clusters. Currently, since we are not running any active workloads, we'll simply skip this option. And finally, the last focus point is creating the internal system user. This is how the HBase service on the source COD clusters communicate with the HBase service on the destination. And it ensures that this is a secure communication and no other COD clusters can participate in this communication. Yeah, I'll increase just the number of mappers to a little large value, and let's go ahead and create the replication. The policy was created successfully. Let's take a look at details of these clusters. So if you see, the policy has a global status. It's currently giving configuring clusters, and it'll prompt for us to do a service restart on these clusters. Let's wait for that to happen. Yeah, it's currently running cluster setup, and we can see the steps which it needs to perform at this point. If you notice, Replication Manager gives a quite detailed information about each steps which it is performing on either source or destination. And that's how admin can take a closer look at what are the steps which are happening behind the scenes on either of these clusters. So all the steps which are involved in the first time setup are performed at this point. So let's go back and take a look at our replication policy. And here, if you see, the policy is onto the next steps, which is, it'll create a schedule. It'll create a replication schedule. Here, the tables which we have specified as part of replication policy, they will be exported from the source COD and imported into the destination COD cluster. It has gone to the next steps, where it is now creating the replication schedule to replicate the actual tables from the source COD to the destination COD. This is the point where it is taking the snapshot on the source cluster. It is exporting the snapshot onto the destination COD, and then it uses that snapshot to make sure that the table is created on the destination COD cluster. Yeah, we saw that the snapshot create command is completed on source. So if you go to the source CM, you probably will see the same commands on the source CM. Yeah, and that's what is currently running on the source cluster. So for one particular table, the command made progress. It in fact even load the snapshot on the destination COD, and then it deleted the snapshot from the source cluster. The command is executing in a similar manner for the second table context. Yeah. At this point, both the tables have, the snapshots of both tables have been exported and imported into the destination. So we should indeed see the tables now on destination COD cluster. Let's take a look at the HBase shell to verify the same. So if we look at the HBase shell and list the tables, we indeed see the two tables which were specified as part of the replication policy appearing on the destination COD. Also take a look at the S3 bucket, which is used on the destination, to see if the corresponding storage is also updated properly. So here, if I refresh, we indeed do see the additional directories created in the S3 bucket, which is used by the destination COD. Final verification is just like doing a quick data check on these tables. So yeah, I will select just a single table view entry and then make sure that that is indeed the same entry. So yeah, we have one row with a bunch of details. And let's see if we have a similar view. Right. So if I switch the windows, it's exactly the identical content which is present on both the CODs. So this workflow explains that we had the initial snapshot which was exported from the source and has imported to a destination. It also sets up a continuous point-in-time replication now for these tables which are a part of the replication scope. So in order to represent the differences between the first time setup, where only when the first policy was ever created, additional steps are performed by the replication manager, which are required to configure the clusters. Any subsequent policies which we create, we do not have to perform these additional steps. So let's just create another replication policy which we can actually see the bootstrap replication followed by the incremental replication as well. Creating the second replication policy. It's still HBase. Here the source is primary COD 2. Yeah, I'll take a simple table. Let me describe the contents of this table as well. So if we go to the source and do scan EMP, it's a small table with a couple of rows, nothing fancy. And this table obviously does not exist on destination. We'll replicate this table and also add some entries after the snapshot replication to show the almost near real-time continuous replication between these two COD clusters. Recovery COD, and no additional steps are required. Yeah, I think I can just give it a whole number of mappers. Great. And the replication policy is created. As this policy completes and basically gives us the details about the further parts when the data is indeed exported from source and imported to destination, we'll actually go ahead and also add some additional data to the destination, to the source, and then can see the near real-time nature of the incremental replication provided by the HBase itself. Yeah, so this is creating the schedule. And if you see, yeah, we are already into a bunch of steps. We just need to wait for these steps to complete. We noticed at this point the ad hoc snapshot command has completed, which means the snapshot from the source has been successfully exported and imported into the destination. So at this point, the table should be available onto the destination COD cluster. Let's verify that via HBase shell. So when I list this, I indeed see the table, and let's check the contents of that table. Yeah, it has the same two rows which were present on the source. So at this point, real-time continuous asynchronous replication is already enabled between source COD and destination COD. So let's perform some additional inserts on source and make sure that that data appears on the destination. So I have a quick cheat sheet for that. That's what I'm going to use here. And we'll add one record, and then let me add one more record, then I think it should be good. Yeah, so scan, we have 4 records here, and at this point, let's just check the data. In fact, it almost instantaneously showed up on the destination as well. So this showcases the nature of a continuous replication which is provided by HBase and how Replication Manager helps to set up basically a disaster recovery scenario where the prod COD is always protected by a backup or a basically DR COD use case. So with that, let me take a pause, and that concludes our presentation of a HBase COD to COD replication demonstrated using Replication Manager.